Or from homework or anything?
I have a question.
Yes.
For the test, is it gonna be evenly split between arithmetic and algebra course?
I have no idea. Yeah. That's a great answer, Jeff. We'll find out tomorrow when I give the practice test out. Normally my tests roughly follow the ideas on the practice test.
Okay.
Yeah. I almost don't want to give out practice tests anymore because some teachers make the test the same as the practice test, which is bullshit, but then people expect me to do that. Like, no, I like to, actually teach stuff and measure if you know it. So if you have teachers that do that, I'm sorry. They spoiled the hell out of you. They need to stop doing that shit. Yes?
We got some question on the homework.
Mm-hmm.
So, from 212 to 218.
So give me an example of one of those problems.
Okay. 5 over 3, sorry.
Well,
C, negative 3, equals 2 over 3, C, negative 16.
cool. Yeah, this one's not too bad. I mean, you can kill the fractions, but do you see why you might not want to? What's nice about the fractions that are in this equation? They already have a common denominator. So maybe it would only be if I had like 5/3 C minus 3/5 equals 2/15 C minus 7. I mean, you see, then I might want to try to kill all my fractions because I don't want to deal with all that, right? But here, this is not too bad. Just remember, a fraction is just a number. So how do I solve any equation? Forget that there's fractions there. What do I need to do to start to solve this for C? What do I need to move?
5 over 3.
I could.
Add 3.
What's a little bit better?
2 over
Sure.
3, so you don't have a negative?
Huh?
2 over 3, so that...
Yeah. So if I subtract this, I'll get my C's together, right? Okay. I think we're at a good spot here, are we? With the heat?
Yeah.
You guys feel good? Catch this before it goes too crazy. Off. I mean, if the problem would have been this. The problem was this, what would you do first on this problem, right here?
Axis.
How? Be very specific. What exactly would you do?
Subtract 2x?
Subtract 2x.
Yes.
What if this would have been a 3?
3x.
I would have freaking subtracted 3x, right? Well, what if it's a 2/3? Okay, I'm going to subtract 2/3, doing the exact same thing. So I can start to consolidate my C's. And what is 5/3 C minus 2/3 C?
3/3 C.
Which is
1 C.
a whole C. I like it. And then, you're one step away. So don't immediately freak out about your fractions, especially if they are already like denominators. Maybe they will go together and naturally disappear. Those came together and disappeared. Because it's 3 over 3, which is just 1, yay. But if you wanted to, you could multiply everything by what? From the very beginning. I could multiply everything by 3.
Yeah.
That would kill the fractions, but it has the alternate thing of making everything a little bit bigger. So it's like a bit of a trade-off. Yeah. It would still work though, totally. It has to.
So you could either do that or you could multiply, but I mean,
Yeah, so let's see. Right, this would be the last step, is that cool?
Yeah.
Right? Because the only thing in the wrong place is minus 3, so if I add 3, I get C by itself. All right, come on, turn it off. What's going on? Now it's too hot again. Shit.
It cannot be negative 13.
Say again? Why not?
Negative 16 plus 3 is.
Okay. I was like, come at me. Yes.
I want to understand it, because the 5 minus 2, right?
Yes.
It's gonna be 3.
3/3. And what's 3/3?
1.
1.
Nothing. Okay. You do it faster.
I overshot my target. Screw it, I'm not gonna miss. Now watch. All right. Some of us desperately need more practice with this. And in most of those cases, I'm almost certain it's you just need to do the homework and get help if you're having trouble with it. I think a lot of us haven't done that yet. Some of us are fine with this, right? And the rest of us are like, well, good for you, but you know, everybody's coming in with very different abilities. So the only nice thing is if you got a bad grade on the quiz and it's because you didn't do the homework, hey, that's in your control. You got control over that, right? So bring it in, control it, get ahead. Okay, maybe. If you're really far behind on homework, come see me immediately so I can help you get caught up. But this kind of problem, you need to be able to look at this as the C's are in the wrong place. I've got to move them one way or the other because the whole idea is to get all my variables on one side, all my numbers on the other side. So that's really what's guiding me as to what I'm doing. Like if I bring these over here, I'm going to have to eventually bring these over there. So I get them on opposite sides. And how do I move something? By doing the opposite of what it is, right? This is plus 2/3, so I'm going to subtract 2/3. This is minus 3, so I'm going to add 3. Now, one of the biggest mistakes on the quiz, a couple of them. I saw people doing this kind of thing here. So if you did this, you weren't alone. I'm not picking on you. You with me? So that's a mistake, right? Somebody with me on that? Don't write that down and circle and say, this is how you do this. What's wrong with this?
Because you're trying to add a whole number to an exponent. I mean,
No exponents here. What?
because you can't put a 2 in an exponent. You can't put the plus 2 with an exponent. That's what I'm
No,
saying.
you mean variable, I think.
Yeah, variable.
Yeah, X variable, right? But more importantly, how can you cancel what this is doing with addition? What is this doing right here? What is this? Multiplication. So how in the world can addition do anything to that? In fact, what is negative 2x plus 2? Negative 2x plus 2. I can't, those aren't like terms, which is what your point is. Right? So what I try to tell you guys, when you're looking at a problem, you got to ask yourself, okay, why is the x not by itself? Stupid negative 2. What's the operation between them? Multiplication. So what do I have to do? Divide by the thing I don't want. Now they do cancel. So that was one thing that happened on a few people's quizzes, was you just saw a negative 3 and you add 3. Even if it was multiplying, you would just add 3, but it can't do that. Addition isn't that powerful. You can't cancel multiplication. Do you guys see what I'm saying? Yes?
Because there's going to be some problems where you only have, where some of the answers would be like 2x plus 3 because you can't add them together in later on, in some equations.
Sure.
Yeah.
Okay. Maybe. So another problem, another thing was this. Let's say it was right? And then I have somebody do this. All right, let me let you absorb. That's a mistake.
Yeah.
Do you see the mistake? Because really, so what I try to do is on the people's papers that did this, I said, no. Follow what you did. What is negative 5 minus 7? Negative 12. Plus, right? X equals. And what is 7 minus 7? 0. So you haven't solved yet. Your brain latches onto the numbers and starts to do stuff. But algebra saves ourselves if you follow it, because algebra is doing things backwards. Your brain doesn't understand that by itself. You got to go, whoa, brain. We got to do the algebra because this is kind of backwards. Right? Maybe?
So how would you do that? Would you?
Yeah, so what's the right way to do this? I can't overload this side. You see what I mean when I say I overloaded this side? Because what's in the wrong place of this problem?
The 5.
No, come on.
Oh, 7.
No.
Negative
5.
5.
Yeah, there's only one thing left, right? So
Through
what?
5.
Where are the X's? Right there.
Right.
They have claimed that side. So he's in the wrong place. So I have to
Positive 5.
add 5. Now I get x equals 12. I like it. Stop looking at that like, oh, math is so crap because you got to do everything. It's not like artwork. Yeah. No, the format is trying to help you keep things where they're supposed to be. Right? So don't just poo-poo the format and go, no, I understand that, but you've got to follow. The format's trying to help you. Maybe. Yes?
So so basically if there's one area alone, you look up to the other area and then you go to
Well, you see if your x's are together,
Yep.
and then you see if your numbers are together.
Mhm.
So there I had all my x's together in one place, so the numbers are what needs to be worked on, and they need to be on the other side. That's the real fundamental part about solving any equation.
Okay. Well, I got all of them right, so I'm just kind of being a devil's advocate.
Okay. Anything else from the quiz or from homework or anything?
Are you gonna times that one by 3, all of them?
Oh yeah, I'm sorry. So if I redo this one, let's see. So if I do come in and multiply everything by 3, right, these cancel, so I get 5c. 3 times 3 is 9, is that cool? Just put it down, Jeff. All right. And then the 3's cancel. And then 3 times 16. So that's the trade-off I told you. You kill the fractions, but you kind of like make everything bigger in the process. But now maybe your brain can catch on to this. What do I do next?
Put your numbers together.
Minus 2c, it makes sense to me, right? Right? Get your c's together. So I get 3c. And of course, what's in the wrong place?
Negative 9.
Crazy ass 9. How do I kill him?
Add 9.
Add 9 because it's subtraction. Okay. Negative 48 plus 9.
57.
They're opposite signs.
Oh, are
So you have
they?
to subtract. Yeah. 39. Negative, right? Because the bigger one's negative.
Yes.
And then the last step is
3.
divide by 3. And what's 39 divided by 3? That's right, kids. Negative 13. Same answer, of course. What was the last thing we did? Let's see. I don't want to say this. Yeah, what was the... Well, this one's a little bit wonky because the fractions kill themselves this way. So we didn't have to actually multiply by 3. But this is really just a reorganization of what we did here. That's why the answer comes out the same. So I did certain things first here and I didn't do them here at all. And vice versa.
First one is it.
Second?
The first
There you
one
go.
is it.
Yes. But I want you to realize that everything I tell you will always work. It's just that they're only useful in certain situations. Other situations, they might make it look much worse than it needs to, right? This wasn't that bad. If you kill the fractions, it wasn't that bad. But you're always going to make the numbers bigger because you're multiplying by something to kill them, right? Okay. All right. That was really a good sound. Anything else before we move on? Okay. And everybody's on board about the homework, and when it says E30,
No.
it means every third one. Not, you don't just go, man, Jeff just mistyped there, over and over and over again, right? I don't know what you guys thought E30 meant. Like,
It
no.
says on there, so.
Huh?
It says on the paper what it is.
I know it does. I know it does. But some people just thought, oh, his fingers went, it's old. Big fat finger's old. He's, you know. It's like, thanks, guys. Okay. So next thing. If you can solve, let me give us a problem here. I'm gonna put one next to it that's related somehow. All right, I'm saying that those two problems are related. I'm gonna solve them the exact same way. And this is where I feel that students say, yep, he's crazy. You guys okay? If I say those are the same problems, does anyone see how? If A was 5 and Y was 10 and B was 25, that is this one, isn't it? So the format is exactly the same. So if I said solve for X, what would you do first here? Why?
To both sides. Take it rid of the 10.
But why? Why didn't you
Because you want to get X by
divide by
itself.
5 or something first? Because you try to get the thing with X in it by itself first. You almost always want to divide last, just in case it might make fractions that you don't want to deal with. Right? So I'm going to add 10 because this guy has the X in it. So what am I going to do over there if I'm trying to solve for X?
Same thing.
Add the Y. This guy has the X in it. How do I get him by itself?
Yeah, the Y.
Add Y. Exactly the same thing. So every student freaks out when I give equations with no numbers in them. I love the student that one semester that said, they're easier because then I don't have to do any of this shit, right? Over here, you got to do 25 plus 10, don't you? Right, so you get 5x equals 35. Here, what do you get? What's b plus y?
B plus Y.
B plus frickin' y, right? You don't have to do it. Just write it down. I don't know what it is. Don't put by. If I put by there, why is that wrong?
Because you're multiplying.
Because that implies multiplication. I didn't multiply by y. You guys semi with me? Not at all? Yes? What happened over here? Please, it's got to be okay over here. There's my x's. So the only thing that's in the wrong place is those numbers. They have to be on the other side, right? So again, how do I look at this? Are my x's together? Yes, they're all right there, aren't they?
Yeah.
Are my numbers together?
No.
No. Some are on that side. Ah, like better. Those things better get in freaking line, right? Yes.
So on that side, would it be like b plus y over a?
We're getting there, exactly. But over here, so plus 10, because my numbers aren't together yet, right? That's what's keeping me straight. But now I'm going to kind of generalize even that, because what if I don't have any numbers anyway? I find where my x is, and I get that thing by itself first. So where's my x? In this term. So I'm going to get this out of here. Get out of here. And what's the last thing I do here?
Divide.
Divide, because that's the only thing I do to kill this thing. So how do I kill the a?
Divide.
Divide by a. Because it's a times x. Kabam. Right? And what do I get over here? Now watch. This is kind of cool. Here's the next level of this. This is a way to solve anything that looks like this. So if I know what A, Y, and B are, this will tell me what X is. What was A? 5. See what I'm doing?
Mm-hmm.
What was B?
25.
25. And what was Y? 10. 10. Do you see how Y is, no, do you see how Y is 10? AX minus Y, 5x minus, that must be Y. And what is 25 plus 10?
35.
And what's 35 divided by 5?
7.
Freaking 7! Right? Sorry. So what we're doing when we're manipulating variables in an expression, in an equation like this is an equation for if I didn't know B and I knew all this other stuff. See, wouldn't that be beautiful? Because B equals this. But what if I know everything except that? Now I want to solve it so I have an equation that works for what if I don't know X and I know everything else? Maybe? Maybe? Not at all, yes?
So you're saying pretty much like every time we solve for x now, we can use that equation technically?
You gotta be careful. If you have an equation in this form, right? That's why, has anyone ever learned this before? No. Because it's not generally useful. How many equations are exactly in this form? Not many, right? There's a few. I don't want you guys to go too far with this. If I have an equation that is in this form, like this one was, then I could use this to figure out what x was directly, instead of doing all this stuff. Where this is really, really useful, let me show you an equation from real life. Wouldn't that be nice? Anyone know what this equation might relate to?
Function.
Degrees, temperature, right?
Fahrenheit?
The rest of the entire world, I was going to say universe, I don't know. The rest of the world uses what measure for temperature? Celsius, because that's based on metric. It's 0 for freezing, 100 for boiling. We, of course, use 32 for freezing and 212 for boiling because we're America, right? Whatever. Sorry. I want somebody to get up and say, damn right, we're America. Shut up. All right. You guys, somebody with me? Okay, so if I knew the Celsius, I could figure out what the Fahrenheit was. But what if I knew the Fahrenheits? What if I had a whole freaking list of Fahrenheits that I had to convert into Celsius? If I did this equation each time, I'd plug the value in, solve for C. Plug the value in, solve for C. Plug the value in, solve for C. I'd much rather solve for C once, and then I can just plug shit in and be done with it, right? Have you guys ever seen this before?
No.
So for example, I love it. You're like, why would I? So what if the Celsius, let's do 30 degrees. I'm sorry, let's do, not this. What if it was 30 degrees Celsius? What kind of day would that be? Let's find out. Some of us might know. Most of us probably have no freaking clue, right? It's sort of like, how big is a decimeter? I don't freaking know. All right. So if I plug in 30, how do I do this? How do I solve it? This is just simplification. 5 goes into 30. 6 times 9 is 54. Plus 32 is 86. Right? Which is like what this room is now. What is going on now? Yes? So a 30-degree day in Canada is 86 degrees here. You guys with me? I like it, right? Okay. All right. So what if I knew the Fahrenheit is 62 degrees? What would the Celsius be? How would I do that? Why did I put 30 here? Because that was Celsius. So if I knew the Fahrenheit 62, where would I put it?
In the front.
I like it. I was hoping nobody said, I'll tell you where to put it, Jeff. You put it right there. It's Fahrenheit, right? So you're going to put a 62 right here, right? So 62 equals 9/5 C plus 32. And then we know how to solve this, right? You with me? So let's see. Minus 32, minus 32. 30 equals 9/5 C. And then we know how to do this. How do we get C by itself? Multiply by the reciprocal, right? So we get C equals 150 over 9, which is roughly, I don't know. What would it be, Jeff? 16.666? Is that right? Nobody's got a Kepler? Yeah? Okay.
Yeah.
Okay, now stay with me. But, all right, so that took me a little while, right? Yes? To plug in for F and then get C by itself. What if I had a big ass list of a whole bunch of Fahrenheits and I had to figure out the Celsius for each one? I would much rather solve for C once and then just plug in all the values, right? So if I solve this equation for C, I've got an equation that works for when I know F. This equation works for when I know C. Do you see that? If I know C, awesome equation. If I know F, suck-ass equation. Yes? That's a technical term. Suck-ass. All right. How do I solve this for C? What's the first thing I would do? Same stuff I did over there. Subtract 32. So I get F minus 32. And then what do I do? Multiply by the reciprocal. I love it. Again, this side doesn't tell me shit. This side tells me what to do, right? I want to get C by itself. I want to get rid of this. Multiply by 5 over 9. So then I get this equation for if I know Fahrenheit, Celsius equals 5/9 times F minus 32. And sure enough, if I put a 62 in there, 62 minus 32 is 30, times 5/9 is exactly what I did do, right? But now I could do it for that, I could do it for 80, for 30, for 17, and I could do it a lot quicker than having to solve for frickin' C every damn time. So if you're getting into math, you want to be able to manipulate expressions before you plug variable values in. And it's not that hard. It's the exact same steps we do when we solve an equation. We're just kind of doing it once instead of like 80 times. I'd rather do it once, right? Okay, let's try a different one. How would I solve? Well, here's an equation we should know. Maybe? Anybody know that one?
Slope intercept form.
Yeah. So I want to solve for M just to be different. So how would I solve that for M? So first question you ask yourself is, where is the M? What term is the M in? Where is it? MX. So I want to get rid of anything else. So what do I want to get rid of? I want to kill the B. I want to get the B done out of there, right? So subtract the B. So what do I get? What's Y minus B? I always want, one semester I had a smart ass, it's like, oh, L. All right, I understand. But I don't know what the hell it is, so I just write it. What's Y minus B? Y minus B. What do I get on the other side? So what's the last step to get M by itself? Divide by X. Trying to get M by itself. Bam. So just a little preview. Some of you guys know what I'm about to say, but if I knew any point and the y-intercept, I could figure out the slope just from those using this equation, because that's what M means. Right? Maybe nobody just said the slope. You know why we use the letter M for slope? Because it's, the theory is it's related to marche, the French word for walk. Because when you're following a slope, you're walking. But that's enough of that, sorry. That's in our future. Okay, let me give you this. So we did the first section of this, we talked about it. I want you to try to do that first problem on here. Just try to do that very first problem. P equals 2L plus 2W. just to make everybody sure that everybody's on the right. What have I done to myself today? Just to make everybody sure that everybody's on the right track. Which term has your L in it? 2L. So which term are you trying to get rid of first? 2W. I like it. Keep going.
So minus 2W.
No, I'm sorry. Is everybody finished with it on their own paper? Yeah. So yeah, how do you get rid of 2W? You subtract 2W from both sides. So I get P minus 2W equals 2L. And then divide by 2. This one was not as evil. There's a few numbers in this one, but anybody know what that formula is for? Length and width, so that's the perimeter. Yeah. I kind of wish you didn't know this formula, because perimeter, you don't need to know any formulas. It's just add up all the freaking sides. Right? Area is where you got no formulas. This is where it gets freaky. Right? How much covers this area? Oh shit, we need some formulas to help us out with that. Perimeter, we know we need 0 formulas for that. Just add up all the sides and be done with it.
Okay, so just P minus.
Yes, so L equals P minus 2W over 2. Now, real quick question. Why can't I kill those 2's?
Why?
Because the 2W.
Same number?
What's being divided by 2?
P minus 2W.
P and 2W are being divided by 2. You can't just kill this because then somehow P escaped being cut in half. You guys see that? Does division cancel subtraction?
No.
Nope, so stop. Okay. So what about the next one? Let's see. Anybody know what that formula is for? C equals 2 pi r? Yeah, buddy. Circumference, right? That's when conference became a night. I know, it's just math has got a ton of stupid freaking jokes in it. You guys know, real quick,